10, Section 2, Chords. The first theorem we need to talk about says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if I have a circle with two chords, in this case I have chords XY and chords YZ. Notice that by notation I know that those two chords are congruent. Because I know those two chords XY and YZ are congruent, I can also say that arc XY and arc YZ are congruent. And this would work the other way also. If I was given that arc XY and arc YZ were congruent, then I could use that to tell me that the chords were congruent. This is a biconditional statement, so it works both forwards and kind of backwards. The next theorem says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So I'm going to have this circle with a diameter drawn in. And if this diameter is perpendicular to the chord, so if it forms a right angle, what this theorem says is that now these two arcs, or these two chords, the two chords that are, the chords has been bisected by the diameter. The diameter is also bisecting arc XZ, creating congruent arcs XY and YZ. So we know that XW is congruent to WZ, the two segments of the chord, and arc XY is congruent to arc YZ, the two arcs that have been created by the diameter. The next theorem says if one chord is a perpendicular bisector of another chord, then the first chord is the diameter. So in this case, if I have one chord and it is the perpendicular bisector to another chord in the circle, what that tells me is that that longer chord that's going all the way through the circle, JL, is going to be the diameter of the circle. This example asks us to solve for x and then find the measure of arc BC. Notice that we have two chords, chord BD and chord BC. Through notation, they've told us that those two chords are congruent because they each have one tick mark. The corresponding arcs, arc BD and arc BC, are given to us as 3x plus 11 and 2x plus 48. Because those arcs are corresponding to the congruent chords, we can set these two arc measures equal to each other to solve for x. 3x plus 11 equals 2x plus 48. I would subtract 2x from both sides and subtract 11 from both sides, and you get x equals 37. I'm not completely done with this problem yet because it asks me to solve for x, which I have done, but then it asks me to find the measure of arc BC. So what I need to do now is I need to take x equals 37, and I need to substitute that into 2x plus 48, which would be 2 times 37 plus 48. Well, 2 times 37 is 74. 74 plus 48 is 122 degrees. If we know that the measure of arc BC is 122 degrees, we could also say that the measure of arc BD is 122, and we would not have to go back and plug in 37 for x into 3x plus 11. But if we did go back and plug it in, we should get 122 also, because those two arcs are congruent. The next theorem says that in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. We've kind of talked about this a little bit before when we were talking about angles, but to measure the distance from the center to a chord, we're going to need to draw a line from the center that is perpendicular to each chord created. So, or each chord that's there. So because these two chords are equidistant from the center, we can say that chord AB is congruent to chord DC. We can also say that arc AB is congruent to arc DC because those would be the corresponding arcs to congruent chords. In this example, it says AB equals 12, DE equals 12, CE equals 7, and they want us to find the length of CG. The first thing I need to do is go ahead and label what they've told us. AB is 12, DE is 12, and CE is 7. They want us to find the length of CG. If you notice, C would be the center of the circle. They also tell us that chord AB and chord DE are congruent because they are equidistant from because they are both equal to 12. They want us to find the length of CG. Notice that would be the distance from the center to the chord AB. We don't really have enough information to find CG directly. However, if we look at CF, which would be the distance from the center to the congruent chord DE, we do have enough information to solve for that one. And we know that two congruent chords have to be equidistant from the center, so if I can find CF, that will be the same as the length of CG. That's what this says. It says because AB and DE are congruent, we know that they are equidistant from the center C. So if we find CF, it is going to be congruent to CG. Notice that CFE, triangle CFE, is a right triangle. They tell us the hypotenuse of this triangle is 7. Now we have to be careful here. The whole chord DE is 12, but we only need the distance from F to E, which would be half of 12, which is 6. So we're going to use the Pythagorean theorem and say 6 squared, which would be the length of FE, plus x squared, which is going to represent the length of CF, equals 7 squared, which is the hypotenuse. Well, 6 squared is 36 and 7 squared is 49. Subtract both sides by 36 and you get x equals the square root of 13. 13 is a prime number. I can't simplify this radical at all, so I'm just going to leave it as the square root of 13. Because CF has a measure of the square root of 13, CG is also going to have a length of the square root of 13. Today's assignment is on page 607. It's numbers 1 through 37 odd and 40 through 47 all.